Hey guys, this is chapter 14, Acids and Bases, part 4. All right, so water can act as an acid and a base. And we talked about it in a previous video, but it's called amphoterism. Water is amphoteric. It can act as either an acid or base. And it even does this with itself to a very, very small extent called self-ionization. So if we have water, a cup of water, I'll make it blue because for some reason we associate blue with water even though it's not colored at all. We have a gabillion water molecules in there. And so some of the water molecules act as an acid and some act as a base, and then we end up getting in that solution a hydronium ion and a hydroxide ion. Now, since water by itself doesn't conduct electricity, very, very, very few of these are actually formed. It would always be this would be equal to this. And if they're equal, it would be a pH neutral. So it would be a neutral solution. It wouldn't be acidic or basic. That's what it's water. It's always neutral. And for pure water at 25 degrees Celsius, what we find is that each of those concentrations are 1 times 10 to the negative 7. And so we call it the ion product constant, but I just call it the K. The Kw, and the W means for water, is 1 times 10 to the negative 14. And so the equation that we can use is the Kw is equal to the H plus times the OH. And so that's going to be 1 times 10 to the negative 14 is equal to the hydrogen ion concentration times the hydroxide concentration. And a lot of the time you'll see them use hydronium instead of hydrogen, but it's shorter to write hydrogen. So that's the way I write it. So this is one of the equations that we'll use quite a bit in this unit. All right, so to summarize this, water behavior in a neutral solution, H3O hydroxide will be 1 times 10 to the negative 7. In an acidic solution, H3O is greater than that, and hydroxide would be less than that because acidic means it's got more acid, so it has more H plus. Now, in a basic solution, the base would be overpowering, so the base would be greater than 1 times 10 to the negative 7, and the hydronium would be less. And so here is that equation one more time. And this is at 25 degrees Celsius. And so all of our calculations will be taking place at 25 degrees Celsius. All right, so using Kw, if we're going to calculate in the solution, calculate the hydroxide in the solution and determine whether the solution is acidic, basic, or neutral. So I know that my relationship is Kw is equal to the H plus times the OH, and that Kw is 1 times 10 to the negative 14. And so we're just going to plug in what we know. So I know that my H is 7.5 times 10 to the negative 5th, so I'm just going to plug that into there. And then I'm looking for my OH. So then I'm going to divide. And I end up getting that my hydroxide concentration is equal to 1.3 times 10 to the negative 10 molar. And so in this one, the H plus, that's a bigger number. Remember, negative exponents cause the decimal place to move to the left. So if you have 10 to the negative 5th, what that really means is 1 over 10 to the 5th. And so 7.5 times 10 to the negative 5th is 7.5 times 1 over 10 to the 5th. So we're dividing by 10 5 times. So 7.5 times 10 to the negative 5th is 0.000075, which is going to be bigger than 0.00000000013. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So since the H plus is greater than the OH, that means that this is acidic. All right, and then we've got a H plus equal to 4.7 times 10 to the negative 8th. So I'm going to plug that in. And then solve for OH. and my answer ends up being 2.1 times 10 to the negative 7. And so by just a little bit, hydroxide is greater than the hydrogen, and so this would be slightly basic. All right, so interdependence of H3O plus and hydroxide in an acidic and basic solution. So if you look at these, if you look at these up here, the hydronium is equal to hydroxide right here, and that's where it's neutral. On the basic end, these are all greater than these, and if you multiply them together, you end up getting times 10 to the negative 14th. And on this end, on the acidic end, the H3O is greater than the hydroxide concentration. And so a pH less than 7 is acidic, a pH greater than 7 is basic, and a pH equal to 7 is neutral. And we're going to get into how to calculate those in the next video. So here's the pH scale. It goes from 0 to 14. That doesn't mean you can't get a pH less than 0 and you can't get a pH greater than 14. This is just where it cuts off, because I think that's where most pH probes measure things accurately, but I'm not really sure why they usually cut them off there. So neutral is here, weakly basic is between neutral, and strongly basic is up here. So this is where stuff like Drano and things like that are. And then strongly acidic is like a strong HCl solution. But down in here where pH 2 and 3, that's like stomach acid, Coca-Cola is somewhere 3 to 4, things like that. So we'll talk more about this soon.